A compression test is often a quick and easy way to identify if a catastrophic engine problem is present, and can also assist with determining the overall health of an engine. Clean debris from around the spark plugs before removing them, and remove all spark plugs on multi-cylinder engines. For more accurate results, compression testing should be performed on a warm engine. Of course, if the engine doesn't start, a cold compression test can still be performed and used to identify if it's the likely cause of the starting fault. Make sure the choke and throttle plates are wide open. Any restriction of airflow through the engine can skew compression test results. For example, a partially open throttle plate can drop compression by 40 psi, more than enough to fail the test. Confirm battery voltage is more than 12.4 volts, as a discharged or defective battery can reduce cranking speed and lower compression. For fuel-injected engines, disconnect the ECU before cranking to disable ignition and fuel. When the starter solenoid is readily accessible, a remote starter switch can be used to crank the engine and may prevent ignition on carbureted engines. Crank the engine long enough for about 6 compression cycles to occur. For an engine in normal to good condition, at least 160 psi should be present. Some engines in like new condition can generate over 200 psi. Multi-cylinder engines should not vary by more than 15% between cylinders. For example, a twin-cylinder engine with 200 psi on one cylinder shouldn't have less than 170 psi on the other cylinder. Some twin-cylinder engines and most single-cylinder models are equipped with an automatic compression release mechanism, often called an ACR. The ACR reduces the effort required to start the engine by lowering compression. These engines will not achieve 160 psi during compression testing and may only reach 60 to 90 psi.